Ever watched a video and just knew what was going to happen next? Like when a ball rolls off a table, your brain instantly connects the dots: motion, gravity, falling. That's causal reasoning, the ability to see how actions, events, and physical laws shape outcomes. But here's the kicker: can AI do this? Or is it just guessing? Today, we're diving into a groundbreaking dataset called CausalVQA, designed to test whether AI models truly understand cause and effect in the real world. This isn't about memorizing patterns or picking up on tricky language clues. It's about thinking like a human, anticipating consequences, imagining alternatives, and grasping the physics of everyday life. Let's break it down. Most video datasets focus on surface-level tasks: what's happening in this scene? Or what object is this? But real-world reasoning is way more complex. Think of it like this: if a vase is near the edge of a table, will it fall if someone bumps the table? A human would instantly visualize the cause, the bump, and the effect, the vase falling. But can a machine do the same? CausalVQA tackles this by asking 5 distinct types of questions that probe different layers of causal thinking. 1. Counterfactuals: what if things were different? E.g., what if the table wasn't there? 2. Hypotheticals: what else could happen? E.g., what if the person caught the ball? 3. Anticipation: what's going to happen next? E.g., will the ball roll off the table? 4. Planning: what steps are needed to achieve a goal? E.g., how would you prevent the vase from falling? 5. Descriptive: what actually happened? E.g., what did the person do? The dataset uses real-world videos, like someone cooking, playing sports, or navigating a room, because that's where the real complexity lies. But here's the twist: the creators didn't just slap on random questions. They designed a hybrid pipeline mixing human intuition and AI tools to ensure questions are fair, diverse, and hard for models to cheat. No relying on word patterns or shortcuts, only deep visual understanding. Here's how they built it. The team started with 16 human annotators who spent over 300 hours reviewing clips, crafting questions, and ensuring everything made sense. Each video cost $52 to process, but the result? A goldmine of questions that push AI to think, not just guess. The process was meticulous. Annotators first asked, is this clip even suitable? If it was too chaotic, it was discarded. Then they anchored the questions with a simple descriptive prompt, like what's the person doing, before digging deeper. For example, if a video showed a person stacking blocks, they'd ask, why did they stack the blocks that way? Or what if they used a different technique? But the real challenge was making sure questions required understanding, not luck. Every query went through a second round of checks. Another group of people watched the video, tried to answer without seeing the correct choice, and flagged issues like unclear wording or biased options. It's like proofreading a book, except here, the goal is to build a fair test for AI. To ground the dataset in human performance, researchers ran experiments with 273 participants to create a human baseline. If AI can't beat humans on these questions, it's not really understanding the world. And here's where it gets really interesting. They even trained AI to generate its own tricky questions. Imagine teaching a model to guess the wrong answers for a quiz. By studying patterns in human errors, it could create deceptively realistic distractors. The results? Even the best AI models today lag far behind humans. On tasks like predicting future events or imagining alternate outcomes, they're significantly less accurate. Why? Because they lack the intuitive grasp of physics, spatial relationships, and the what-if thinking that comes naturally to us. This isn't just a tech problem, it's a stepping stone. As AI moves into real-world applications, like smart assistants, self-driving cars, or robotic helpers, we need systems that can reason about cause and effect, not just react to stimuli. CausalVQA is a vital tool for pushing that boundary. So next time you watch a video, think about the invisible layers of reasoning behind it. And remember, the future of AI depends on whether machines can see the world the way we do.